I welcome you all viewers and dear students to this online classes organized by the State Council of Science, Technology and Environment. Today's class is the continuation of the last class, that is Chemistry, Chapter 1, Chemical Reactions. We will continue with the types of reactions, so let us begin. We will do third type of chemical reactions, that is chemical displacement reactions. Okay. When a more active element displaces a less active element from its aqueous solution, then the reaction that takes place is called chemical displacement reaction. So let me just give you a simple equation. If suppose in this compound AB, this A is a less active element, okay, and this C is a more active element. Because C is more active than A, C will displace A from AB. So it forms CB and A is the displaced element. Okay. How do we know that an element is more active or less active? We will know from the activity series of metals. Okay. Activity series of metals is just the arrangement in a decreasing order of the elements, increasing in the decreasing order of their electropositive character. Also, if you see in this table, you see lithium, potassium and all these elements, actually this cadmium should be down after iron, so I just wrote here. As we go down in this metal series, the electropositive character of these elements decreases, and also the chemical reactivity of these elements decreases. The elements placed above this activity series are more active than the elements placed in the lower part of this series. So we see this lithium is placed at the highest position, therefore lithium will be more, or lithium is the most reactive element, and this gold is placed below, just down of this activity series, therefore gold is the least reactive element. Okay, so let me give you an example of this chemical displacement reaction. Copper sulfate in a copper sulfate solution, if you add iron, see, since iron here, iron is more active than copper. This one. See, this is below iron. Therefore, iron is more active or most reactive than copper. Therefore, in this solution, iron will displace copper from its solution. Okay, therefore we get iron sulfate and copper is displaced. If suppose in this iron sulfate solution, if you add copper, since copper we know it is placed below the activity series of iron, it is less active than iron. So copper cannot displace iron from this solution. Therefore, if you add copper to the iron sulfate solution, there will be no reaction taking place. Okay? So, this reaction, we know it takes place because we know the activity series of the elements. Okay, we'll move to the next reaction. Chemical double displacement reaction. Okay. reaction, when two ionic compounds in its chemical aqueous solution, if they react by exchanging ions or radicals to form two new compounds, we call that reaction as chemical double displacement reaction. So in simple equation, I'll just write. Okay. We see here that these ions, okay, the ions that are here in this compound, they just exchange among themselves and we get this products. So this is called chemical double displacement reaction. And under this reaction, we can classify it into two types of reaction. One is precipitate reaction and the other is neutralization reaction. Okay. In this first type of chemical double displacement reaction, the precipitate reaction, it is a double displacement reaction only where one of the product, it forms an insoluble salt, hence it forms a precipitate. So I'll give you one example. If suppose in this lead nitrate solution, you add potassium iodide, okay, so exchanging of ions will be there, lead iodide plus potassium nitrate. Okay, first of all, let us balance this equation. See, we have two nitrate here. Here there's just one nitrate, you just add 2 here, multiply 2. So potassium becomes 2, so multiply potassium by 2. And iodine here is 2 and here also 2. Lead is 1, here also 1. So therefore the equation is balanced. Okay. In this reaction, this lead nitrate is colorless solution. Even this potassium iodide also is a colorless solution. When we combine these two, a precipitate is formed. This is a precipitate. Why? Because when you perform this experiment, when you add these two solutions, precipitate of lead iodide is formed here. This is an insoluble salt. An insoluble salt of lead iodide. That means this salt is not soluble in any solution. Therefore, you will get a precipitate here. Actually, the precipitate here is yellow in color. So, and this solution is also formed. So therefore, because of this formation of this precipitate, this reaction is known as precipitate reaction. Okay, let us move to neutralization reaction. Neutralization reaction is a reaction when a base and an acid reacts together by exchanging of ions and the products are only salt and water. So, let me give you an example of neutralization reaction. Let's here example. I told you when an acid, say hydrochloric acid, and a base, say sodium hydroxide, when these two react together, the only products formed are just salt and water. So the salt formed here is sodium chloride plus water. Okay. This is an example of neutralization reaction. This is salt. This is water, as you know. This is an acid. This is a base. Any acid, if you add with any base, if you let them to react together, the only products, remember, the only products that formed are only salt and water. If you see in this equation, the equation is already balanced because if you see first for hydrogen, there are 2 hydrogen here. Even in this side, there are 2 hydrogens. Okay. Let's see for chlorine. Here is 1. Here also 1. C for sodium, 1, here also 1. C for oxygen, 1, here also 1. So this reaction is already balanced. Let me give you another example of this neutralization reaction. Say you take the acid, sulfuric acid, okay, you let it react again with this base, or you take any base like potassium hydroxide also is fine. So I'll take potassium hydroxide. Let us change. The only products formed are only salt, so potassium, sulfate and water. So this is an acid, sulfuric acid. This is a base. Product is salt and water. Okay. So here also, here the reaction is not balanced. So let us balance first. If you see here, there are 2 potassiums here, 2 potassium atom. So you balance here, you add 2 potassium here. So therefore 2 potassium, 2 potassium. So let us see for hydrogen. There are 4 hydrogens here. Here 2, you get 4. Here there is only 2 hydrogens. To balance, you multiply by 2. Let's see for oxygen. Here 4, 5, 6. Here also 4, 5, 6. So the equation is balanced. Okay. So this is all about the types of chemical reactions. So let us do oxidation and reduction reactions. Oxidation. An oxidation reaction is a reaction that takes place when, okay, for oxidation this one, when there is addition of oxygen to a substance and when there is removal of hydrogen from a substance. What about reduction reaction? It's just the opposite. Reduction reaction takes place when there is removal of oxygen from an element or from a substance and when there is addition of hydrogen to a substance. Oxidation and reduction reaction are just opposite to one another. So I'll give you examples so that you understand. If copper oxide is led to react with hydrogen, okay, this equation is already balanced if you see. Okay, so see first, oxidation is a reaction when there is addition of oxygen and removal of hydrogen. Okay, if you see this copper oxide, it reduces to copper. That means from copper oxide, oxygen is removed. So therefore, when removal of oxygen takes place, reduction takes place. So therefore, copper oxide is reduced to copper because oxygen is removed from copper oxide. Okay, if you see hydrogen, oxygen is being added. So therefore, its oxidation takes place. This is one oxidation. So therefore, this is oxidation. And remember, when there is a simultaneous reaction of reduction and oxidation taking place, we call that reaction a redox reaction. You can also call this one a redox reaction. Okay, let me give you some more example. Magnesium, when led to react with oxygen, magnesium oxide is formed. So, yeah. This one just balance first because oxygen there are 2, so here also 2. Magnesium I have added 2, so it is also 2. So see, magnesium in the product oxygen has been added. So therefore, when there is addition of oxygen, its oxidation takes place. So magnesium is added with oxygen in the products, therefore oxidation takes place. What about oxygen? Oxygen is being removed, okay, and then gets to and then oxygen from here is being removed and added to magnesium. So oxygen itself is being reduced. Okay, so this is reduction. Let me give you the last example. Hydrogen sulfide and added with bromine. Let me balance. There are 2 hydrogen here, 2 bromine. Just add 2 here. Okay. See, here there is no oxygen, so therefore you check for this one for hydrogen. Okay. See, here hydrogen sulfide is being reduced to sulfur. So therefore, this hydrogen sulfide, hydrogen is being removed. So therefore, its oxidation takes place. Because hydrogen is being removed, so the reaction is oxidation. Okay. And say for bromine, bromine is being added with hydrogen here. So therefore, its reduction takes place. By simply using these conditions or definitions of oxidation and reduction reaction, we can classify or we can check these reactions whether where this oxidation or reduction has been taking place. So this is all about oxidation and reduction reaction. So next, we'll see now what is the effect of oxidation in our everyday life. Because of oxidation, okay, corrosion takes place. What is corrosion? Corrosion is just the formation of some undesired compound in the surface of a metal. Usually they are metal oxides or metal hydroxides. Those they form on the surface of the metal, then we call that one corrosion. Corrosion also takes place in silver. Okay, we see where silver is in this activity series. We see silver in this activity series. It is placed quite below in the activity series, so it is quite less reactive. But then still, if you leave silver for quite a long time, some darkish color, dark color, it forms on the surface of silver. This is because in air there is the presence of hydrogen sulfide. Okay, so because of these, they get in contact with silver, and then silver sulfide forms. So therefore, this is that black color which forms on the surface of silver. So this is the corrosion of silver. What about corrosion in gold? We see gold is placed at the bottom of the activity series. So we know also gold is the least active of all the elements, and it does not react readily. Even if it gets in contact with moist air, it won't corrode easily because of its least reactivity. So that's why gold is usually used to make jewelries, and they last a very long time because of its least reactivity. So, okay. Lastly, we'll do rusting. Okay. Last, we'll do this rusting. Usually, rusting, it occurs in iron. We know that iron, if you see in this activity series, it is placed quite above in the activity series, so it is more reactive. So this iron, when it gets contact with moist air or if you leave the iron rod outside the ring, you will see after a few days some brown color substance forms outside that surface. So we call that one rust. Okay, that brownish color substance that forms on the surface of iron, we call that one rust. Okay, and the process of formation of rust, we call it rusting. So how does rusting occurs? It is because, okay, when iron it gets in contact with moist air, that is oxygen with water, ferric oxide and ferric hydroxide are formed. Okay, this ferric oxide, this is that brownish color which corrodes, or which makes the iron rod corrodes. Okay, this is because of this reaction. This is the reaction of rusting. Okay, so first of all, let us balance this one. We see here iron, there are 3 this side and here only 1. So let us first balance for hydrogen. There are 3 hydrogen here and here there are 2. So to make it balanced, just multiply with 2 hydrogens here, you will get 6 hydrogens, and here to get 6 we just multiply with 3. Okay. See for oxygen, here oxygen there are 3, 4, 5, and here there are 2, 3, 6, 7, 8, 9. There are 5 here. How to make 9? 3, just add here 3. 3 into 2 you will get 6. Add with this 3 oxygen you will get 9 oxygens. And here also 3 plus 2 into 3, 6. 6 plus 3 you will get 9. So 9 oxygens. So oxygen is balanced. Let us see for iron. Here there is only 1 iron. Here 2 plus 2 you will get 4. Just add 4 here. So this equation is balanced. Okay. Okay. Now there must be some solution to prevent this corrosion. There are some solutions. Okay, how to prevent corrosion? What you can do is, you can just paint through painting. You just paint the surface of iron or surface of metal, then it will protect the metal from corroding. Number 2, what you can do is you can just oil it and grease the metal. This also prevents corrosion. And the third one, you can just do plastic coating. You can just coat the metal with plastic, then it will prevent them from corroding. And because why? All these, when you cover, okay, it protects the iron or the metal from getting in contact with moist air. Okay, so therefore these are few preventions how to prevent corrosion. So this is the end of this chapter, and I really hope that you have understood whatever we have talked about. And let us meet next time. Until then, stay safe.